Oh, yeah, Francisco Perel, could you mute your, I think I can mute you.
Yeah, we met at one of the conferences in San Francisco.
Yeah. I was just asking if you can mute yourself so then we can reduce the echo that's coming in.
Thank you.
All right, thank you. All right. I guess what we'll do now is I'm just gonna go ahead and do one last thing, and then we will start this on at 10:05 specifically. And then I'm gonna ask. All right, and then while we're here, I'm just going to post a quick question for everyone, and this will just help us guide the conversations and help answer the questions as much as possible. So if you guys go ahead and fill out the survey, that'd be amazing. And then the first person up on the docket will be Antonio. So I will screen share. All right, let's 10:04. So we'll start doing an introduction for Antonio really fast. Antonio, do you want to turn on your camera and then we'll go ahead and briefly
Yeah,
introduce you?
hold on a second. There you go. Can
All
you
right.
see me?
Yes. So just to give everyone a little bit of context, what we're going to be doing today is we're going to give everyone a quick preview of 4 demos that we built out on the tool as a team. The real purpose of this week was for us to go ahead and go understand how people use BAML, what are some of the pain points of it, and like how complex of an application could we build if possible. First up is going to be Antonio. Antonio worked on a bot that is able to go and analyze our Discord, where you guys have been asking a bunch of questions and making feature requests and helping us go ahead and see how could we take that and make it more actionable. Antonio, I'll let you take it off from here.
Right, so yeah, I guess I'll just show how my bot works, right?
Let's do it.
Hold on. Can you see my screen?
Yes.
Cool. So I basically wrote a little Python script that can basically read these Discord messages from our Discord server, and it classifies them as either bug reports, feature requests, or just normal questions about BAML. And then it basically displays like a Notion table with all the messages. So I'm not sure if you can see. Can you see the table?
Yeah.
Yes, we can.
Cool. So you can see the messages here. Oh, I can wrap this. So these are Discord messages. They're filtered by category, feature requests, questions, bug reports. And then in the case of threads, we can also get a summary of the conversation here. So that way you know it's worth responding to this or continuing the conversation. And we
What?
also get, sorry?
Do you want to show it running really fast, Antonio? Let's start with that. Let's just start off with a real live demo of it just like running and filling this out.
I was just showing like what's this, how it's supposed to work, because it's gonna be kind of slow. But yeah, I can show it in action.
Let's see it in action. And the whole point behind this is what one thing we do as a team is every Friday, what we do is we go over the Discord, all our Discord issues, all our GitHub issues, and decide what is one feature that we can all go build guaranteed and actually ship by next Monday. It helps us stay motivated and shipping fast. But a big pain point is me and Aaron literally spend hours the day before scrolling through the Discord, finding all the issues, scrolling through the GitHub issues, finding everything, and being like, what can we actually go do? So the question here was, could we do it accurately? And then one could be also dedupe issues. Could we go ahead and identify problems that aren't working and then help us go ahead and just buy back a couple hours of our time? So what Antonio built here, let's let it rip.
Yeah, so this basically tries to kind of automate finding all these issues that we can work on. So I can just call the bot and give it a start date. Let's say we start with August, and then I could give it an end date. If I don't, it'll just do from the start date up until today. So end date is gonna be today. So we're gonna try to find all the messages. I mean, obviously it's not gonna display all the messages, but just those that are bugs or features. So it's gonna filter them out. And yes, run this. It's gonna log into Discord, create the Notion database here. And at some point, it's gonna start displaying messages.
And this is
And
where
so
you guys
right,
can kind of see like how did you do the streaming part of this, Antonio? Like how did you get that to work?
yeah, I'll explain that once it ends. You can see a summary here. And it also links GitHub issues if they're related to the message or PRs,
Oh, that's
depending on, yeah, depending on, can't even click on this. It depends on which one is the most related to the message.
that's awesome. So then like we can actually pick issues that are actually not handled versus ones that are handled.
Yeah, we could also check if they're closed or open. We can get a state of the issue.
That's pretty cool. And then how have you found it in let's look at a couple edge cases. I'm sure you've been looking at a little bit of the data. Let's look at some of them that you had and just take a look at like maybe like the thread summaries for one of these, like the bug report one that just popped in, issue 2048. Let's just take a look at that. 248, the first one, yeah.
Yeah, okay. As was the summary for this one is not ready yet. I think it's
Okay.
still
So
still running.
you actually have a pipeline that's running here that's going to go ahead and
Yeah, it's because everything is kind of running concurrently. It reads messages from Discord, classifies them, then it has to summarize threads and find issues. All of those are running concurrently. So now you can see that the summary is ready for the thread. So I guess we can check the thread on Discord. So found out about BAML earlier and been trying to use SvelteKit. So this is, I guess, the thread about this particular bug in there. So let's see the summary for this is.
No, that's cool. It even lets them know that the bug was fixed, so we can know that this is like even though it's a bug report, it's like actually addressed already in a later version.
We've got a question from the audience.
Um, how are you matching issues? So we got a question from someone. How are you matching issues? Semantic similarity between the comment in Discord and the PR comment, or is the code itself being inspected?
No, I'm just matching them based on the title and the description or the body of the issue.
Using
Now,
semantic
ideally,
similarity or an LLM?
LLM. Ideally, I know it should be stored in like a vector database and you should use that. But what I'm doing is I'm just sending them in the prompt as context. And then I'm just asking the LLM to return the issue number. And that's how I link it.
Nice. Have you seen any hallucinations pop up here?
Well, from time to time, it does hallucinate and return like wrong IDs, and then I can't find it in my code. But it doesn't happen that often.
Awesome. And did you add a filtering step for that to make sure that it only finds IDs that are actually valid?
Yeah, well, the code doesn't crash if it hallucinates, but it's just gonna skip the one that's wrong. It's just gonna skip it.
Is the scraping bot part of the code custom built by you, or are you singing a or are you using a third-party API?
What do you mean by third-party API? I'm using the Discord
API.
Python client, and that's the Discord API.
Nice.
The Notion one to just display all the stuff here, and the GitHub one to get the PRs. So I can show it to you.
Awesome. And then one last thing that we should do really fast is can you show one of the most interesting BAML prompts you wrote while you were doing this?
So there's the BAML prompts.
Yeah. Let's pick one of the ones you found interesting and how you structured it really fast.
So this is the one that classifies messages. The classification is done in batches, let's say, because I don't want to send one request per message. That would
Yeah.
be too much. So you basically get a list of messages. Each message has an ID and then the content of the message. Then you basically ask the LLM to classify all the messages into one of the categories, which is this thing here. It's either feature, bug report, a question, or and categorize, because otherwise it's going to fail. So this is the one that we ignore because we don't want any of this to be on Notion, because then we would just copy Discord on Notion. Doesn't make sense. So we just filter for these categories. And yeah, that's the prompt, like little system prompt to let you know that we're dealing with a language here, and then just classify whatever you get
And it
and return.
and it looks like one other thing that I'm noticing is you have some test cases. Can we show one of the tests that you have, like just so we can like go ahead and see how you were iterating on this and how it works? So let's run tests for one of those.
Yeah, so the test is giving you the list of messages. And then if we run this, we get here the classification. Like for example, the first one, BAML should support recursive types. That's a feature request. Found a bug. That's the bug report. How do I install that? That's the question. And the other one is just general feedback. It's not any of the above, so just uncategorized.
That's awesome. And then we have a couple more questions here, uncategorized enum, and we'll go into it. We'll cover all these questions in a little bit. We're going to try and hit all the demos and give them all 10 minutes. All this code that Antonio wrote, FridayBot, is going to be available in our BAML examples repo, so you'll be able to dig through it and take a look at this yourself. And we'll add a little bit of a README. It looks like you already added one for how to go run this. So I'll put a link to the repo at the bottom right after a few seconds. Thanks, Antonio. That was really cool. It was really cool to see it running. It was really cool to see the Notion populate from the Discord itself. And I know we had just a few minutes to go over the code, but thanks for describing it the way you did. It was really thorough. Up next, we've got another demo coming up. And this time the demo is going to be one of our biggest one of the biggest and most interesting things that I saw, which was we all saw computer use happen. I'm not sure if you guys all saw it, but computer use was the idea where Anthropic could go ahead and almost like manipulate your computer using an LLM. Now, the question we asked was, could we draw a horse? Could we draw something way more fancy than just boxes and lines on a screen? And this was really trying to push the limits of what LLMs today can do. And I'm going to let Greg over here take it over. Greg, are you live?
Yeah.
Awesome. So Greg is going to go ahead and share, and what he's going to do is just show what we learned from this experience of can Anthropic draw a horse?
Anthropic draw a horse. Before I spoil you with an answer, I just wanted to talk about like why is this an interesting question? We've all seen generative AI images. They're incredibly beautiful, but it's a little bit black box how they're created, and they're not the most steerable thing in the world. So yeah, Claude demoed their computer use framework. It can drive your mouse and keyboard. They showed it doing a little bit of art, and it can do things like enter data into spreadsheets based on what it observes in a video. Really amazing stuff. And I thought it would be interesting to see how far we can push that, because like art that's done through computer use could be a little more steerable than your stable diffusion-based stuff. You could even imagine interesting like two-player drawing scenarios where the human is doing some stuff and they hand it off to the AI for some other parts, get the shading on the upper lip perfect, and then the human goes back to some other bit of the artwork. Also, drawing is a super agentic and like cognitive task that involves lots of planning. So it's a great stress test for LLM's ability to do those things. Now we'll answer the question. The question's answer is no. We can't really draw horses. So what you might have expected based on what you see from Dolly, Sora, and Midjourney is this beautiful ML cake, but what you get in the mail, when LLMs use MS Paint is, the reality state of the art today is not quite what we get from those fully like black box solutions. So yeah, I'm gonna tell you a little bit about my exploration to why this is, and then we'll try to replicate that whole framework in BAML, and then use BAML to sort of play with what we imagine the pain points are for an LLM who's trying to draw. So first, just a quick primer on how computer use works. Rather than read this list to you, I'll like run the demo, Anthropic's demo, so you can see it working, and I'll talk through what's happening as it's going. So I'm running a Docker container locally that contains something called the computer use client. And what that does is it lets you send prompts to Anthropic. So I'm going to send this prompt to Anthropic. And then what Anthropic is doing is it's looking at the prompt and it's deciding which computer use action it needs to have carried out on my side locally to fulfill my prompt. So some of its options are it can request a screenshot, it can request the coordinates of the mouse, it can request a click, it can request a drag.
No.
Oh, okay, thanks. Oh yeah, I also want to say, please ask questions. I'll have my friends try to monitor the questions if I can't see the questions coming up, and it'll be more fun if you ask questions during this. So yeah, Anthropic generates a request for an action, and then the client locally executes that action. It'll take a screenshot if asked, it'll click if asked to click, and then after it does that action, it sends all the data about what happened locally back to Anthropic to get Anthropic to generate a new request. And yeah, so you see that process happening on the bar on the left. So it's a series of requests coming from Anthropic. And then on the right, you see the view of my virtual machine where a horse is being drawn pretty nicely in this case. Sometimes you do get, well, okay, yeah, I'm like leaking the secret here. This is a really good horse for drawing within computer use, and this is about as good as it gets. If you randomly do this a few times, you won't get anything better. Okay, so we will stop this so I don't use all my tokens. All right. Yeah, so the initial results are kind of mixed. Here's me prompting a first smiley face. The computer use demo drew this face, half smiling, drooling face, and then it responded, the smiling face has been drawn and saved. So that sort of reflects what we just saw, with the horse demo. After this, I prompted again. I said, "Can you please erase the mouth and make it look nicer?" And what the system did was draw a couple lines on top of the mouth. Admittedly, if you squint, it does look a little bit more like a smile. And then the system reports back. It says, "I have erased the original mouth and drawn a new one that's wider and has a nicer curve to it. The smile now looks more natural and friendly." So yeah, we see that there's some sort of discrepancy between what the system sees, what the system's drawn, and how it's subjective report on the quality of the image. My original plan was let's take whatever amazing drawing abilities computer use currently has and extend them. But I realized quickly that we've got a lot of work to do to get it up to like a better level. Yeah, so what I went down was a little bit of an exploration of like where in this process is the drawing going wrong. So I did a little bit of like spatial reasoning exploration and just asked the system to do basic spatial reasoning things like click. If I draw a smiley face, can you click on the left of the face? Can you click on the right? Can you click where the nose should be? And this kind of basic sanity check was the first place it failed. And I think this is going to lead either us or Anthropic working directly on computer use to sort of tune things to perform better in the future. It's just this basic task of localizing things in the image by reference and getting the mouse to go right where you want it. Computer use does an amazing job of picking tools from the toolbar, but there's something about registering coordinates in terms of an image that's tough. Do I see a question from the audience?
Yeah, there's two really interesting questions. One, how expensive is it? I think what we found expensive wise was it wasn't too bad. It's like maybe like how much, do you remember the cost that you saw? It was like a couple bucks.
Back of the envelope, experimenting with this all day, yeah, a few dollars.
Yeah.
And yeah, it's not horribly expensive. In terms of tokens, it's a lot of tokens because what happens is every frame of the screen, I'm not talking about 60 frames per second, but every time there's a ping pong between the client and Anthropic, the entire history has to be sent up. So that includes all the screenshots.
Yeah. There's another question, but I want to, and I think it's related to what you're talking about being able to go click on specific areas of the screen. That one really interesting thing was we were all as a team super excited about the fact that, hey, computer use came out. We believed that the technology was going to be good enough to go do things that were more interesting. One really interesting thing Greg found out after we implemented it was the testing, it wasn't working. So the debug path that we found of saying that, hey, let's just figure out where it's broken was a really important learning. And the breakdown of click on specific key points in the face became almost like an eval that we did where we as a human would just go see where it clicked and could just see if it was good or bad. We could obviously use more AI or even a search or something else to go double check that. But the next test was actually exactly what when she asked in the chat was how well does it do with imitations?
Oh.
Do you have the image of that?
Oh yeah.
Right,
That's
yeah.
actually my next slide. So yeah, great job anticipating that. So the next thing I did was I drew a star. This is Vaibhav's prompt here. And I asked the system, just copy the star, please. You can't see it in the screenshot, but what computer use did was it drew 5 points in a perfect pentagon. They're to the left. I'll put my mouse over them. I can't find my mouse.
It's where the mouse is in the picture if you guys see it.
Oh, thanks.
Yeah.
That's my mouse.
Okay, yeah. Sorry. So we're having some technical difficulties with my mouse, but believe me that to the left of my star, there are 5 teeny tiny points, which Anthropic drew perfectly in a very nice pentagon, and then it put 1 point in the middle. What it did after that, you can't see in this still, was it repeatedly moved its mouse to those various points. It visited each point 3 or 4 times, and then it said, "I'm done," and it produced the text that I've written on the slide there. I've now drawn a second star to the left of your original star. They're similar in style, both having the same 5-point star shape and inner lines forming a pentagon in the center. Obviously, that's not true of the image, so that's a hallucination. And one, I guess, interesting science question that doesn't pertain to the rest of the talk, but I think it's fun to think about is, did Claude hallucinate just the nice words, or is Claude hallucinating an image of a star? Like if you could go look at the activations of the neurons and then register them back to whatever, superposition of features, would you just get nice word features, or would you actually get whatever the representation of a pentagon is?
And for anyone really doing multimodal stuff, this was actually one of the key things when we started thinking about that to think about, which is really, where is the problem? Is the problem the fact that there genuinely is a star as far as the model can see, because those 5 points look exactly the same in the embedding space as the drawing on the right? Or is the model just trying to be nice and tell you it did something, even though it knows that it didn't?
And it could also be prioritizing the tokens in the text that, went through the whole flow of drawing the star. And then once it finished that, it was like, I see all the steps to draw a star. Therefore, the star is already drawn. And so maybe there's some experiments here where
You have to remember, sometimes I'm just listening in the video conference.
Scan as a separate document, and this is a
Can
separate.
I mute you, Joe? Sorry.
Yeah, sorry.
Okay.
Yeah, so then, it could be the case that if you delete all the context and only show it the image and ask it, is there a star? Are there 2 stars here? It may just have a different example. But yes.
And then I'm gonna have to stop before we get too deep into this, sadly. But all this code that Greg wrote is also going to be a version of this is going to be displayed in the BAML examples repo, will you be able to dig into and actually go run it yourself and go find the same findings if you go back to Greg's little smiley face and get your own little erasers not working and everything else yourself as well. Awesome. Greg, I'm gonna go ahead. Do you have any last thoughts that you want to share?
Yeah, so check out the repo if you want to see how you can do all this in BAML. And you might be having ideas of how to solve some of these problems if you could just like add a little bit of information to the event loop. Yeah, we won't have time to go through that, but I promise it is a nice experience in BAML to add those things. Yep, and that's all. Thanks.
All right. Thanks, Greg. That was really fun. Thanks for sharing the slides as well. So now what we're going to go do is address one of the biggest problems that we have. Sam, give me 1 second, which is documentation. As you guys know, we're writing a new programming language, and documentation is one of the most important things for us to do. And as every other developer in the world, we hate writing docs, but we have to do it anyway. And writing really, really good docs can be extremely tedious. For example, one of the tasks of just adding hyperlinks into your doc, so when someone goes to one page, they can quickly jump to all the other pages, just takes forever. And as you remap pages, move them around, it can become even more frustrating. So Sam here took on the task of saying, what if we didn't have to do that manually? What if there was some way to automate the whole process? And Sam, I'm going to let you take it out over from here.
Cool. Here, cool, awesome. Oh, I see. Yes, we're on that camera.
Yeah.
Okay, so this is our documentation. So obviously, the first thing I had to do to go and actually like test this is go and set up documentation without links. So the thing I started with is actually taking our existing documentation and then just stripping all the links from it and setting up. And so now we have an app that we can just point at our documentation and say like, hey, suggest a whole bunch of fixes. And what I ended up doing, it's taking a little second to run. But this is the underlying prompt for all of this. So it runs through and says, on per document basis, hand back, and I'll make this one a bit wider so you can see it. But the prompt is here. For every link, show a suggestion, hand it back in the output format. And this is what it ends up being. Oh, what? That is not my.
Oh, sorry. My bad. I was screen sharing. Yeah.
Got it. And so the output format ends up being suggests like, tell me what the current link text is, tell me what the current destination is, if there is any, because most of the time we're going to be running this on our actual docs. Give me an actual suggested link, whether it's within the docs website or if it's on some other website, and also the line number. And then the file, we're passing it in with line number annotations, and then we embed the sitemap of all the links that we know about, and just feed this all in and ask LM to do it kind of zero shot, but also few shot. And so just to hop back to the results, this is what we have. We have a whole bunch of link suggestions. Next.js starter now points at the actual Next.js starter docs. Live demo points at promptfiddle.com. React query will point at the TanStack docs. And so if I just apply these two, and so this is the actual, this is running on my local machine, you'll notice that it's pointing to localhost, and the links are not there. So if I just apply those two, there we go. I have a hot reload loop running in the background for this one.
So one thing I want you guys to think about here is Sam, how did you get to the point where you made it not how did you decide, how did you get to the point where the links were correct?
Yes. So it was a mix of two things. The first was that for some links, the choice of model made a difference here. Haiku is actually pretty good at following instructions for a specific subset of the input prompt, and would generally be pretty good at returning docs within the documentation sitemap. So like if it was on docs@boundaryml.com, it was good at handing back a link. If it wasn't on the website, it was really bad at that. That was the thing I noticed when I was like doing eval runs on every page in our docs. The other side of it was also just adding an actual automated verification step of saying like, okay, I am getting back a link. Is it a link to our documentation itself? If so, I can just check if it's on the sitemap. That's really easy. The other side of it is I just need to make sure and like actually do an HTTP request to it and check if it's there or not. And there's more sophistication we can add here. I can go in right now, actually, for example, like looking at the prompt, I'm only asking it for a single link suggestion. I can go and ask it to produce multiple suggestions, but then that creates more, that has a very fundamental trickiness of coming back to this loop. Because right now, this is essentially a yes/no interface without any feedback mechanism. So the thing that I would have to go back and do if I wanted to add more sophisticated retry or select mechanisms is I'd also have to go through in this UI and say like, okay, how am I going to present multiple options to the user? What is that experience of if I choose a different option going to look like? So right now, everything that's handing back is getting verified. But that's entirely done through manual heuristics of A, is it in the sitemap? And B, can I just make an HTTP request to it and get back a successful response?
Yeah, and I guess one really interesting part that we noticed when we were doing this was actually, I remember this question that we talked about, Sam, when you were starting to debug this, and I think a lot of people might have this question, which is when you start building an application like this, how important is it to actually build the UI to change your iteration loop? Because I think when we started building this, we built this as a terminal-based application.
Yep.
It was purely a script that we ran. How helpful was actually adding the UI element to it?
The UI made a huge difference. It's a lot easier when you can just click around and like ask it to go and do different things. And in particular, like one of the things I'd actually started with was in the same vein of like, is CLI better or is like UI based better? It's a lot easier to scroll through a list like this when you're doing an eval set, as opposed to, I don't know if I have as opposed to like scrolling through this entire mess, which like is readable. Like but I had to spend a fair amount of time like on actually just like making this readable because I was using this as my own eval loop of like if comparing like, and like this is how I was able to say like Haiku versus Sonnet, which one is better at which, but this like terminal based version compared to being able to see everything like right there, just the human cognitive processing makes that so much easier.
Yeah, and I think this was the way I would summarize that for everyone is that if you're building an LLM application and you don't really have a large testing suite that you can go run in an automated way, it's probably a real high value add for everyone to go and build a small little UI component to go render it. And one of the nice things about having structured data, like the way you weren't just having the LM spit out text, you're having it go spit out like, I want on this line, I want you to change this, which then allows you to build these nicer UI components, which dramatically changes how much more fun the experience is for actually like reviewing these things. And now let's talk about the idea that you had, which was, I want to suggest multiple links. All of a sudden, it becomes really easy for us to go ahead and perhaps add a little button here that says, oops, I'll draw. That said, oh, I'm drawing in white. That says, fix with AI right next to here. You press it, you run a separate prompt purely on that specific data structure, and then you just go ahead and get a new update. This is only really possible with structured data and a strong UI loop. And when you have a lot of data, this would be the main takeaway that we really have here. Not only can you build really highly accurate pipelines, but spend some time on the UI. It will make it feels slower in the beginning, but it will speed up everything else downturn.
Yeah.
Thanks for sharing, Sam.
Yeah.
That was really cool. I'm really excited to like, if you guys ever see broken links on our dots now, you know who to blame. It's Sam. And we don't think we'll have them because we have guaranteed checks to make sure that they're actually correct. So we'll run this every single week and we'll have new links updated all the time. We should be able to hyperlink everywhere now. Thanks for that, Sam. And again, like everything else, this is going to be on BAML examples.
Oh yeah, what did you use to build this UI?
So I actually did not go with, so that's, I think the standard recommendations that have Mindshare are Gradio or Streamlit. I haven't personally used any of them, actually. This was the first time I was doing a UI-based app in Python. This one is actually built using Shiny, which comes out of the R community, but Hamel Hussein, who you've sort of probably read one or two of his blog posts. If you haven't, they're amazing. You should go check them out. But Shiny is where I picked that recommendation up from.
Cool. All right, thanks, Sam. So we've done 3 demos so far. We did one demo on we did the first demo on the Notion update, can Claude draw, and the last one was about making documentation really good. Now, last one, we're gonna do some live demos. We tried to build a fairly sophisticated pipeline. And this was with myself and Aaron, so I'll let him come on the screen as well. And we put 2 people on this because it was a lot of work. And the whole ambition here was, what if we could go ahead and can you bring up? What if we could go ahead and actually help people write BAML in a more automated way? Because one of the most annoying things about BAML is writing BAML. It's why any code from now on. I want to use Cursor to autocomplete everything. So we started tackling that problem.
I'm sharing.
Can I screen share first with the demo?
Yeah.
So we started tackling that problem, and I just want to show you a demo of what we put together. And we're going to release this for everyone to go use in the community, either this Monday or the following Monday. We'll see how, based on what it goes like. So I'm going to share my whole screen, and we'll just start this from here. So let's just start with a very basic prompt. What is at alias? An alias, as you guys know, is a way for us to go ahead and describe what this does. So you can actually, you'll see over here, it's able to answer questions about our documentation. It uses a RAG pipeline over here. But what gets really fun is say, show me an example using classification. Let's see what it does now. And sometimes this works. It is. And it's starting to build some classification. It looks like it's going to use symbol tuning to go and show me this. And boom, we're seeing a live example of BAML code being generated on the fly with test cases. And then you actually get the same BAML playground that you're used to seeing with all the prompt previews that you can go run. And you can actually see what the prompt is doing down here. And you're seeing it's plugging it in. You can go ahead and see the token visualization. We're working on rendering this as well. You can see the raw curl request. I just leaked my API key. Oops. And then you can always run the test as you're used to doing. Oh, let's use OpenAI Anthropic really fast. OpenAI, GPT 4.0. And let's actually make a user prompt while we're over here. User. And like with everything else in BAML, you can actually go edit the code. It's always code first. And once the code is edited, you can actually see the prompt as always. As we toggle around in different test cases, you can go see them like you're used to being able to do. And then you can still run everything, have it stream in, have it do the parsing, and just see the same experience that you're used to seeing in VS Code. So not only am I able to go ask questions about it, but I can actually have it generate code for me to go do something. So let's do a more complicated example. Show me an example of function calling.
Hey, good. How are you?
Hey, let's mute.
Yes, I'll mute him. And then can you man the chat?
Yeah.
And then it's going to go ahead and go do this. It's going to go ahead and show me an example of function calling. And every now and then we'll get some of the bits wrong. Like it'll actually like put some backticks over here. So let's go fix that. Let's go fix that. And then we're back. Oops. Oh, second.
You're gonna save it, right? I don't know.
I'm working on the save button, to be honest. The save button is almost there.
Oh, there's more stuff here. Yeah.
There we go. And now we can go ahead and see this, and boom, I can go run these tests, and I can just see what it's doing. Oh, I don't have my Anthropic API key plugged in correctly. So I can go fix that out. But you're able to get the same experience here. So anytime you're able to want to go write tests, you're able to just go write those tests in a slightly nicer way, and then actually have your users go ahead and understand it. And if you want to port code over now from LangChain or Anthrop or Instructor or any other library, it should be really easy to go and figure out how to go frame this problem. And as we make our docs better, this will get better. And as you guys go ask more questions here, we'll get an idea of what kind of questions to go build. But before I go and talk about what else this can do, I want to hand it over to Aaron to kind of show what a pipeline like this looks like, and really what the flow of building something that can go anywhere from answering documentation questions all the way to actually like generating code. How do we go do this?
Yeah, so the first step when you're designing a chatbot or some sort of AI agent is to just start with a diagram. Let me make this bigger. So just start with a diagram. That's the best way to just get started, because if you just try and, because LLMs can do anything, it almost makes it harder to code with them, because you're like, okay, how do I split this up into pieces? Do I make the LLM do everything, or like small bits at a time? And so here's what we came up for our pipeline. You get the user context, like a list of messages, into a chat prompt. So purple means it's basically a prompt. And then the chat, this function can generate a bunch of like tools to use. So like one of them is a project generator. Another one is like just explain the user's question. Another one is other, and another one is like basically doc search. And so then the LLM chooses what to use there. And if it chooses doc search, like for example, when Vaibhav asks what is alias, we just do basic RAG, ensure we have the information, and then ask the LLM to explain it again. That's like the basic flow. And then for generating a project, which is where you see the BAML code and you can interact with it, we actually are splitting this into a couple pieces. First, we actually generate a plan. So there's actually another box here that's not here yet. But we generate a small plan of what we're going to do, which will let the LLM just think out loud on like, how are we going to solve the problem in code? Then after you have a plan, it writes a bunch of BAML prompts, and we generate all the BAML code that we need. And then after that, we can do more stuff. Like we can generate more Python code. Maybe in the future, you actually run the Python code in this website. And the last thing that we do is generate BAML tests as well.
Why did you break down the step of generating tests into a separate prompt?
So the reason why I did that is because if we want to generate more things after generating the BAML code, like for example, maybe we want to generate Python code and tests, you can do that in parallel. So it's just an efficiency thing. And the last thing is that splitting things out also helps you, it just helps reduce hallucinations. Like the less context there is in the prompt, the better your output will be. Because you're not asking the LLM to do 1,000 things. Like we're literally asking the LLM to write a whole new syntax, and there's a bunch of rules that we have to prepare it with. And so that helps.
One question that I always like to ask is, when you're going down this road of actually you want to dive into more how it generates the plan and how it dynamically writes new prompts. We'll go into that in a second. That's a great question. I think one of the most interesting questions that I like to ask here is, how did you come up with this loop? And like, how much of this was draft 0? How much of this was like draft N?
So, I mean, we definitely went through a couple drafts. Like the first draft was just me trying to do like maybe one big prompt and figure out like what I need from there. I was just like, let's just figure out what the chatbot does if I just give it all these instructions. But I did know from the start that like you just have to use like some sort of tools. Like the LLM needs to be able to use some sort of tools, right? One of them is clearly doc search. Another one is like maybe you have all the context and the LLM can just explain you in a different way. Like the user's like, I don't understand. Please tell me like I'm 5. And then for that, you don't really need doc search. You just need a tool that is just like explain the content. And then just looking at V0, I don't know if you guys are familiar, v0.dev. they have, and also Anthropic. Anytime you ask Anthropic for like a React app, it generates like this special component that looks like a, I don't know if you,
I'll screen share.
it just looks like it's just a separate, like a very unique component that like tells you that there's a project and like there's special things that you can do with it.
Yeah, like in our example, for example, all the code on the right is AI generated, main.baml. But we want to be able to do things.
Are you screen sharing?
I am.
Oh, okay.
It's at Vaibhav, it's a screen. All the things that I really want to be doing here are based off of the BAML code. So if I can't reliably generate BAML code and make that a custom UI component, it is impossible for us to go build this playground. It just will not work. So in our case, we almost had like the burden of figuring that out at the very beginning with no real clause for it. And then there's some prompting things that you guys are noticing. Like for example, it generates backticks BAML because it's trying to output like markdown inside of a JSON object. One cool thing while building this is we have learned some improvements to our parser that we're going to make. So we already support like generating multi-line code without escaping and everything. But what I would really love to do is be able to parse triple backticks and not have to worry about this. For anyone else generating code, we feel the pain. We're going to go solve these problems and make it so that you just don't have to worry about it.
To answer one question, is doc search a vector DB retriever? Yes, we use Pinecone for this.
Yes. And then what we do critically, can you go back to your architecture diagram, Aaron? What we do critically for this is actually the fact that once doc search gives us back the answer, we throw it back into the chat loop because sometimes the documentation that doc search pulled out may not actually have the right data in there. So we actually throw it back in there and it might go back to doc search again because after making one doc search, it may need to make another. And this is just the loop that we run until it's ready. Similarly, when we ask it to go generate code, you can imagine it doing the same thing. Before it generates like a code of aliases, it looks up, maybe our mega prompt that describes all the concepts has enough information about aliases, but we released a new feature recently called, we released a new attribute called check. Can you pull up the check documentation? Where we actually go ahead and let you,
oops, that's a wrong redirect.
Where we actually will go ahead and actually like let the LM go ahead and where we let it do validation. Now we have two ways to solve this problem. Either we can update our mega prompt, or we can send it back to doc search and say, oh, the user is asking for check. I don't know what check is in this mega prompt. Let's go find the context to add additional instructions into our mega prompt, and then go ahead and produce this example page. So we can kind of feed doc search in as this way to get relevant context until you're ready to go answer the question. And once the model is ready to go answer the question, it can go ahead and actually then finally produce a good answer. That's why sometimes in that demo, when I was going to go render it back to the diagram, it can sometimes take a little bit for the LLM to go and actually show you some final exit moment where you as the user are seeing something, because it's actually running a couple loops of this behind the scenes. Now, one dangerous thing about this is what happens if it runs in an infinite while loop and just continuously does doc search, because you're asking a question that doesn't exist and it's just going to run forever. The way you can restrict this is you can actually put a wrapper in your software of saying how many times you're allowed to call the chat function in any one given user message. If you call it up to 5 times, then we're good. If it calls it more than 5 times, just tell the user, sorry, I can't help you. Can you reframe the question? Kind of, but the only difference that you'll get with Cursor is that it won't be as accurate. So while you could add the docs right to Cursor and it will do a pretty good job, the hardest part about that is how do you guarantee that it generates a test every single time? It's kind of like, for those of you, how many of you guys have actually, can you just type in the chat really fast, how many of you have heard of V0? Just like give me a thumbs up or something. A few people have heard of V0. I'll just show you what V0 is really fast because it looks like people have it. And I think it's pretty cool. And I use it all the time to actually go do this. And Cursor can do this too, but so can Anthropic. But let's just start a new chat and I'm just going to say like SaaS pricing calculator. And it does something very similar for UI components, where it goes ahead, figures out some components, and then it then renders the code for you. What it does is it uses two specific libraries, like it uses Lucid icons and then shadcn. Now, can Cursor do this? 100%. But with AI, one of the hardest things to do, as we were seeing with all the tooling and demos that we showed today, was you always have this balance of generality versus accuracy. The more general of a system you have, it's really nice, but you'll never be able to, you'll have to do more work to get it to do exactly what you want. In this case, if I ask Anthropic to go ahead and generate the same component, they probably won't necessarily use shadcn. They may not use Lucid icons. They may not use the same theming that I use. But V0 knows that it's already using shadcn and knows that it's already using Lucid icons. So if I'm doing zero effort, then I can go just plug it in and it'll just work. That said, we use a library called Jotai for managing state in React. V0 sucks at generating code that does this. Why? Because it's just not specialized. So you always have to strike the balance between generality versus specificity. But because BAML is so self-contained, and it is kind of a little bit more isolated than everything else, we can do something much better by forcing it to go do this. For example, one of the things that we do is without any prompting, we generate test cases. Normally, your code may not go actually add test cases. You'd have to add a bunch of rules to go do that. And there's just some level of optimization that we're able to do ahead of time. And we can just make this better and better and better. For example, let's say that there was a thing here where you wanted to improve your prompt or add something like add symbol tuning, add chain of thought, add more advanced prompting techniques. Because we have tooling to actually go parse this code, we could just go add chain of thought to this prompt directly without you having to really prompt or teach the LM what chain of thought is. It's just the amount of work that you would do. Hopefully that answered the question. I'll pause here for the last 5 minutes. Does anyone have any other wild questions or any other general questions they want to throw out there? Feel free to just raise your hand or unmute yourself. Either one is fine. Or type in chat. All right. Well, in all other cases, what we're going to do. Oh, how you build agents with BAML. Yeah. We can go to, it's really a diagramming code. Do you want to show some of the code, Aaron?
Yeah, I can show some of the code.
We'll show that in a second. And we'll pull up some of the code while we're at it. How you go do it. Have you tried BAML DSPY? What we've actually found most of the times is verbose. A lot of prompting libraries like prompt optimizers, including Anthropic's prompt optimizer, including DSPy, what they do is they actually generate incredibly verbose prompts. So while it can kind of help, the reality is the more verbose your prompt, the worse quality of output you'll likely have. So we would actually recommend writing the prompt manually and taking a look at it and just modifying it by hand rather than actually going to go ahead and having an AI generate the prompt, at least in the beginning. But if you have a bunch of test case, computer use in BAML, yes, so Greg's demo will be live and you'll be able to go see exactly how that works to do computer use with BAML.
Yeah. Hi. Hello.
Yeah, there. Hey, how's it going?
Yeah.
Can you type out your thing? I think your audio is breaking up quite a bit. Meanwhile, let's do
Okay.
an example.
Give me a sec.
Yeah, can you type out? And meanwhile, I'm gonna go answer the question about Gustavo how to build agents with BAML. Let's dive into that, Aaron.
Yeah, so here's
Zoom in.
the basic prompt. One sec. Here's the basic prompt. So there's a chat prompt right here, and it just outputs an action. And so currently, we could also output like an action and some text as well. There's many ways to like model this, but for this we just chose a very simple thing where we just choose one action, and from there we'll kick it off into other prompts. So we do the chat message, get an action. If it's documentation search, we get the related docs and then answer the question. If it's an explanation, we just like call the explanation like prompt here. If it's generate an example project, we just plan the project and then we generate the project. So while we don't have a loop at the moment, we're like thinking of adding a loop. So it's just like more generic and actually just like figures out all the information that it needs to answer. Right now, it's a little bit more hard coded because the problem space is a little smaller and we know what we need to give it to like just create a decent prompt from the start. And so this is the current architecture.
Yeah, and one thing to note over here as you guys go look at this is, let's go ahead and look at the actual code. Once you're able to break down your problem into these type of sequences, function calling or agentic architectures are really just doing this. All they do is, let's just show you how to go do this really fast. You can, let's say we had an action called done. All we do over here is this. While true, oops. Right over here. We just do while true. Oh, I did put in the wrong place. Whoops. Where is the action?
You just command Z probably.
It's right here. So I went ahead and did all this and I put a while true loop over here. And all I do is say case done break. Oh, go ahead, save. Yeah, and now case done break. That's all I have to do. And now I've basically built an agent. And the only thing I have to do is somehow update this BAML messages loop on every single update that comes into this. So as the messages come in, I just do BAML message.push and I just add this in. And now I've built an agent. An agent is really fundamentally just a while loop around a action selection with routing for how to handle that action. That's all function calling is really doing. And it won't take that long. You just have to go and just figure out how to go help the LLM indicate that it's actually done at some point so you can stop, or if your tokens run out, etc. In other use cases. Hopefully that answered that. And yes, we'll share out some of this code for you guys as well for actually building the agent. We actually have a couple demos that are already built out that do the agentic work for you. I think there was a demo we released a little bit ago called Notorious RAG. That'll do that. As we're at the end of the hour, we'll stay on for a couple more minutes to actually go ahead and exactly, Vignesh got it. It's multi-agents. It's literally just multiple separate while loops cooperating with each other. That's the best way to think about it. The best thing that you can actually do without actually doing multiple. The best thing about having all these things be completely separated is like Aaron was talking about in that diagram that he showed. Why do we generate tests and Python code in separate calls? Because we can actually do them in parallel. If we do it in the same call, we're suddenly beholden to calling the LLM just singly and once. To show you and by the way, while we're at this entire recording will be posted on YouTube. Before I take up a bunch of everyone's time, we'll stay on for an extra 15 to 20 minutes to answer any questions if you guys would like to stay on. Everyone else is definitely welcome to hop out and head over. All the code will be available, like I said, on our github.com/foundryml/BAML examples, and should be there by end of day today. But we'll also send an email to everyone that attended and with all the links to all the projects with a brief summary and the YouTube video link as well. But now onto the extra section. I'll go ahead and just screen share and I'll show you guys a couple more examples of what I meant. So for example, we have this demo right over here. That's like our recipe generator. And in our recipe generator, I'm going to go ahead and ask it to go do stuff. For example, generate a recipe of chicken tikka masala. And one thing you're noticing is I'm actually able to generate these spinners on each individual component as it's being generated. So not only can I tell you that, hey, I'm working on this section of the recipe and these ingredients are done, but I can give you a state update of exactly what's going on. So when you build agents that are much more fine-grained and much more controlled, then we can see ingredients are ready, I'm working on the instructions, and it's just rendering them out for me. Not only are you actually able to go ahead and build an agent that can give really precise information here on exactly what's working on, but you can actually get massive speed ups by building out agents in smaller chunks. If they're smaller chunks, more parallelism, more accuracy, but it is a little bit more work on your end. And it's just a balance of what you want to strike as a developer. No. So actually, this is one giant prompt that's actually working, and one giant prompt, but because we're using structured data, we're actually able to we have a way to actually know whether or not this is what step we're actually working on over here. This whole code, if you go to BAML examples, and I'll post a link, you can just view the source and see exactly how it's rendering this exact example. And I'll post Aaron, can you post a link? This is right over here. I'll post a link in here. Right there. And that's all it's doing. And one thing you'll notice is not only can I do this, what your code is. Yeah, I'll show you exactly what that is. Would be called, oh, that's a good idea. We'll add a prompt to here as well. And just to show you like what exactly this is doing, if I actually go generate vegetable stir fry, you can notice that this number can actually be multiplied while it's streaming even. And the reason that I can do this is because the thing that I'm doing here is completely being rendered on the UI side, but there's a scaling factor that I'm applying. Purely UI. The LM told me that this will make it for 4 by default. You can see number of servings 4. I'm just scaling it by 4 and rendering it in a nice, pretty way. And there's no way the LM would actually render these 1/4 questions, for example. I do that in rendering because what the LM gives me is just a number. So it'll render 2.5. But I want to make sure that because the recipe site that it renders it beautifully. And then when people do something silly, like try and do a prompt injection, where it's like, I'll show you a different example where you can actually see the failure a little bit better. Like in the case of like generating resume, like in this case, I'm going to tell it to do this and just tell me the instructions. Normally, if you try and do that, you might get some text like this. But if you're doing structured data or some sort of prompting, you're able to go get answers that look like this. Call and ask, can we do a breakdown of exactly what an agent is and what it looks like in BAML versus Python? Let's spend the next 10, 15 minutes actually diving through some real agentic code. And I'll show you another example that we have. Let's see, where did my VS Code pop up? Can you guys see my VS Code? No, you cannot. Share. I'll just share my whole screen and we'll see how dangerous that ends up being. File, open, recent, notorious RAG. Open folder. One second, I have a bunch of repos here. So I just have to find the right one. Okay. So this example right over here specifically is, sorry, I'm working on a very tiny screen. How do I hide? Oh, there we go. I'll hide this. I'll do this, and then we'll actually run some examples. CD web app, npm dev. Cool, that's running, and then CD API. And I have to go look up the command to go run this. UV run. Oh yeah, I guess that's just this. UV run. What did I do wrong?
Hello.py, no?
That's what I thought, but it wants me to go install something. Oh, is this poetry? Oh yeah, sorry. Poetry run. Come on. PyProject.toml. 1 second.
You can just walk through the code.
Yeah,
and
I'll just walk through the code.
what BAML is doing. So
Oh,
BAML
shit.
doesn't do like the agentic workflow that's in Python. What we declare in BAML is just the prompts for now.
Yeah. So here's what we do right now. So I'll just show you the pipeline step of exactly what this pipeline does. So what this pipeline does, and I can show you in the UI side so you can actually go look at it. And I have some historical examples already saved here. So what this pipeline does is a user asks a question. As we ask a question, it's going to do a couple of things. The user says, take a ticket from, it wants to go ahead and ask, how would I actually go do this with BAML code? The first thing it does is it formulates a RAG query and says, how do I actually go extract data over here? Once it formulates a RAG query, it will then go ahead and actually say, oh, I'm ready to answer the question, if it has sufficient answers. Otherwise, it'll make multiple RAG queries. It's similar to what we did. Then a human will actually be forwarded the exact response that the LM made and take a look at this. And the human can actually say good or bad. If they say good, then we'll send it over to the user. Let's find one with multiple examples. Sometimes when the human gets a response, we'll actually deny the request and say, it's too verbose, make it shorter. And then the model will say, okay, I don't need to do another doc search. I will just make it shorter. And then it'll make a new shorter response and the human will approve. And then other times, let's see if I can pull up another example. And then other times what it'll do is it'll actually go ahead and sometimes even do another RAG search after feedback because the thing that the human told it to do was actually not good enough to go answer this question. So what does this pipeline actually look like? And I think this is similar to that flowchart diagram that Aaron was showing at the very beginning. And I think before we look at the BAML code, it's really easy to just think about this from a pipeline standpoint. All we do in this pipeline is we say that we're going to limit the number of steps to 5. Then in every single step, what we're going to do is we're going to go ahead and just first formulate an answer. And when we formulate the answer, 60, what is this at? Let's update this, 67, nice. Once I formulate an answer, I will get some response. And what formulate answer does is formulate answer responds with one of few different types. It either responds with a RAG answer or it responds with, let me put this down to the bottom. Oops. Where's formula response? Either responds with a RAG answer. Oh, and this was me just showing people more about BAML. It'll either respond with a RAG answer over here on the right-hand side, a RAG query, or a final answer. A RAG query will contain the intent of RAG action attached to it, and it'll have a question of how we actually search the docs, because the question we ask the docs could be different than the way the user phrased it, because we know more about BAML than the user does. For example, the user may be like, how do I rename something? And we know that's an alias concept. And then we can also filter it. So the place where we do the RAG could either be documentation, Discord, or both. Because a lot of times we have the answers living in our Discord and could be referenced by a previous answer. So based on what this responds, we just see if the instance is a final answer, we'll do some stuff. And if it's a RAG action, we'll do some stuff. And we'll run this in a while loop. If it's a RAG action, all we do is we get all the results of the RAG query. We inject it as part of context, as part of the chain that's running on. And then we'll just push it into our context by appending it there. And then our context will again just get passed back into the next formula, the same formula answer query, and be run in a while loop until it's ready. If for some reason we've hit too many max steps, we'll actually just raise an exception, say no answer found. And then we'll broadcast that to the user as well. And then lastly, let's say the LLM says, I have done all my RAG search. I now have an answer for you. When the LLM has an answer, it'll tell you the reason of why it thinks it has a final answer ready. Then we'll actually call a totally separate prompt and actually tell you exactly how to go ahead and answer the question. And we actually do this with streaming. And then when I go ahead and go get this answer, what does this answer prompt do? This answer prompt will literally take the context, print it out, and literally tell the user to specifically answer for this question. And the premise is the answer exists somewhere in this context somehow, because we've already determined that another LLM, the previous call, has already said, I've done enough RAG, I've queried it out. And now that I've done this, I'll get a string response. But because we're so specific on the response of being super accurate, then what we will do over here is we'll actually not send this out. We'll actually send this out to our server to say, hey, go ensure that a human actually approves this answer. And the human can tell us two things. The human can actually tell us this is good or this is bad. If the human says it is good, then we just send the response back and we're like good to go. Now when the human says this is not good enough, there's two things they could do. They can actually say, screw it, I don't want the AI to do this anymore. It's good enough, but I don't want to really prompt it to get it correct. So just abort and let the human take over. If the human sends a string as feedback, my exit prompt, the human will literally take over. And they don't actually type in my exit prompt. They press a button that triggers my exit prompt. And then all the button says is, I'll take over. And then lastly, the other thing that happens is if it's not good enough, then we take the feedback that the human gave us and add it back into this context object that we have. And this context object says, this is a draft of the answer that we got based off of this answer question prompt, not the reasoning. And then we'll go ahead and actually add the feedback from the admin. And we call it admin, not inhuman, because admins just have more power. And then they're actually able to go ahead and go get the answer out of this. And then the other thing that we do that is really critical is we reset the amount of steps the LM is allowed to take again. We give it 5 more steps. The premise is at any given time, use up to 5 steps. If a human gives you feedback, you refresh your step count back to 5 steps. And this is kind of how we're able to go and control this all the way down. And the thing that you get out of this, and I'll show you some working Discord bots. Where is this? I have it right here. So I'll show you some interesting responses that the model does. It's actually able to go ahead and not only tell the person that it's working on it and that constantly gets updated on every single step. And if I had this running, it would be much nicer. But if the human says, I'll take over, it can actually tag the person that says that they'll take over and say that this person will go tag it. So you can actually easily find the thread as well. And this interaction, again, is really driven by having deep control over the agentic loop that isn't just like handing it off and say, hey, to some other library that says, just run a while loop and go run this. Hopefully, Colin, this was a good enough deep dive into exactly what the BAML code is responsible for, which is really just a simple take in a message, get a response back. And then you can write while loops, for loops, if statements in whatever order you want with the language of your choice with really good type safety and accuracy. So then you can actually build your actual agent. Awesome. And Justin, yeah, thanks for this. We should definitely probably write a blog post on this. It took us a while to go build out these agents, and that's why we spent this last week kind of building, having everyone on the team go build these out. Any other questions from anyone?
There's 2 minutes. Scroll back.
Oh, I missed some. What are the questions that I got?
Chris Watts says, are you guys planning on adding any native RAG?
So RAG is probably not something that'll be added directly to BAML because, to be completely honest, there's a couple of reasons why we don't think adding RAG natively here makes a lot of sense. And I'll show you why. I want to jump back to actually showing you why we don't think RAG is something that we should control. And a big part of it is the way that you inject context into the prompt is really, really, really important. You can't just render, like a lot of times people will take JSON objects and render it into the prompt. Let's see what that looks like on prompt fiddle. Just so I can show, oops, what happened there? And I think this point gets lost by a lot of folks. A lot of times when you get RAG, maybe you have some document that lives somewhere and you'll just add it in. So if I add something like this into my prompt, and with RAG, it's going to look something like this, like title, article about something, content, and maybe your content is like markdown content or something. So it's going to say something like hashtag. Ooh, what is this? Oh, that's a bug. We should fix that. Oh, I know. It's because I have to do this. Sorry. I have to block off. Oh, syntax highlighting breaks. We should fix that. Foo/n bar. And this is what your prompt looks like. This is a horrible prompt. It's going to be really hard for you to do this. What you really should be doing for all your RAG content is actually writing something like this. Something. And actually, like literally just write the article here. Content. This is just way easier for the model to ingest. If we do RAG, we actually believe that it's going to be harder for you to go do these. And it's just really easy to pass in the context as a parameter, or even as like a string array parameter that you can loop over and actually render it exactly how you want in the prompt. And there's no real reason for us to go add that integration with a vector database when it's just a simple API call there with not much abstraction. As we build out more, we probably will go ahead and figure out some way to do it, but it's just not a priority right now. Vignesh asked an interesting question about, so is streaming with structured outputs allowing you to know when a field out? So the way that we actually did it for that specific example, why don't I just show you what that code looks like? Because I think that's interesting. Is generate recipes. And we don't have a feature for this in BAML, but we are working on this where you could actually go get the state of it coming out. So let's just look at the source code, because I think the source code is always a source of truth. Why think hard about it? Recipe.tsx. And believe that this is it. Here's how we do this. We actually have a, where is this? We actually have a flag on ingredient list renderer. Boom. And we can actually know what the state is. So we actually just track the state based on here, and I'll show you how the state is managed. The state object gets passed in from here, sorry. Oh, nice. So the state object actually gets computed right over here, and I'll show you how the state gets computed. And we do this for every single object. And this is how we learn that we probably want to go do this. One, we just check if it's loading. So loading is something in Next.js that we do provide as a service where you can just know if something is loading or not. Then if it's loading, we look at the streaming data and we just see which of the fields are actually being populated. If we're loading and then we're working on the instructions, and the instructions have at least one instruction in them, we know we're working on the instructions. If they have none, then we know we're definitely working on the ingredients. And we're able to go do this because the actual code for describing this, BAML get recipe, lists out the fact, and I can't wait till we have syntax highlighting on GitHub. We're almost there. With 200 public repos, we can finally get syntax highlighting for BAML on GitHub, which is going to be really exciting. But when you actually go look at the actual recipe over here, ingredient is listed out before instructions. So ingredients from the LLM will always be returned first before instructions does. So we can just know whether or not we're working on ingredients or instructions based on where we're at. And then if serving tips starts coming out, we know we're done with instructions, we're working on serving tips. It's just a way to go track this. And soon the BAML type system will be able to just give you that in TypeScript during streaming as well. And then for arrays, the way that we're able to do it for every individual ingredient is we actually can look at the array and say, if we're partially working, if the state is currently working on ingredients, the last element in the array is always going to be actively worked on. So we just did this as a hack. But the BAML parser actually knows this a little bit better. And to give you an idea of what that actually looks like, I want to let you guys think about these numbers. So when you guys think about streaming numbers, for example, typically when you stream numbers, it kind of makes sense to stream them in and parse them as you want. But if you're streaming number 5,300, all of a sudden you're having massive changes. So if you're visualizing a graph, for example, and you're visualizing years are just not going to work because every single graph is going to snap to the back and say 2, then the year 20, then year 2,202, then finally year 2025. And that's just going to be a big struggle for someone to go and debug down. So what we do in BAML is instead of having it stream numbers like this, we actually do what we call semantic streaming, where we'll only give you the number when it's completed. And now you can imagine that we do this not just for numbers, but actually entire data models itself. So that in the recipe example that we were looking at, it becomes almost easy to go build out a UI like this because we can guarantee that the only things coming out are entire completed chunks of anything that you specifically specified. So that's how you could go do that, Vignesh. A couple more questions that I saw. Okay. Separate loops. Hopefully I didn't miss any other questions. Did I miss any?
Tried BAML plus DSPY, or is that over?
I addressed that one earlier. Generally DSPY or Claude's and prompts are just going to lead to much, much bigger prompts. And then the reason that you probably don't want to end up doing that is because, let me show you guys again. One of the things that you'll run into when you go do this is a lot of prompting can be improved by actually writing structured prompts like this rather than actually adding the instructions in here. Instead of saying that the date should be ISO formatted, let's say I put that into my prompt. And I actually put this in my prompt like this. The problem with this prompt is not the fact that it's going to be formatted. It's just that look how far away this is from the actual date field. If I actually show the tokens, the LLM is going to have to like somehow take this instruction, understand it, and then associate this with this date field, which is like 1, 2, 3, 4, 5, like around like 20 or 30 tokens away. It's just more complicated. So the closer in proximity you can keep your instructions to the aspect of the data model that you're trying to produce, the better you can constrain the model. And that's kind of why prompting don't.
Sorry.
That's kind of why prompting techniques don't work that well. Cool. I think that's it for today. Hopefully this was fun and hopefully this was high value of everyone's time. As you guys have more questions, definitely join the Discord to ask more questions. And then we hope to ship some of these features out for you guys soon. And look forward to the email that we'll send out later today. All right, guys. Thank you so much. We'll talk soon and we'll try and do these more often and more frequently.